Hello, my dear students. This is my lecture first on base of instantaneous axis of rotation for rigid bodies. Actually, what is the instantaneous axis of rotation? Instantaneous axis of rotation is assumed to be at rest, okay, when there is pure rotation. For example, if we consider a rigid body like this, and suppose there are 2 points A and B, and velocity of A is given V and velocity of B is given Vg. Both velocities are parallel, but they have different magnitudes. Suppose Vb is less than Va, so as we know, A will move more and B will move less. So with respect to B, the motion of A is forward. Suppose the gap between them is D, and this D will remain fixed, no change. Means with respect to B, A is in circular motion. And circular motion, then in this case we have to draw a line. Means this point is rotating like this and this point is rotating like this. Both will complete their one rotation in same time period, therefore omega will be same. Omega is angular velocity, and suppose this point is called instantaneous axis of rotation, and suppose the distance of C from B is x. Therefore B is moving on circular track of radius x, while A is moving on circular track of radius b plus x. But omega of A and omega of B will be same. That omega will be equals to VA. As we know, omega is equal to VA upon R. R means for A, this radius will be d plus x, and same omega for B, that is VB upon x. So we can find, on comparing them, we can find x and put the value of x, you can find omega. This is the instantaneous axis of rotation. This is ICAR, okay, instantaneous center of rotation. Is it clear? And this is the part which is mostly comes in many competitive exams. Like this, we will use this another. So VA upon d plus x. For example, I am using the data, and suppose VA is equal to 10, and VB is equal to 5, and D is given 2 meter, and VA is 10 meter per second, and VB is 5 meter per second. Because the board is small, so I am using this. So we can put the same value. VA is equal to 10 upon 5, 2 plus x is equal to 5 upon x. Therefore, on solving, x is equal to 2 meter. X is equal to 2 meter. We see this ratio 10, this is 5, and this is 2, then this will also 2, because VA upon VB is equal to this R1 and this R2, R1 upon R2. We get 2 meters. Simple question. Now, suppose the question comes in another way. These velocities are not parallel in any arbitrary direction, like this. And this is a rigid body, and suppose point A is here and point B is here. And the velocity of A is VA and velocity of B is given here, VB. They are not parallel in any arbitrary direction. In this case, We first see where is the instantaneous axis rotation. For this, we draw perpendicular on both velocities, and where the point of intersection occurs, this is the instantaneous axis of rotation C. And suppose this is at a distance RA and this is at a distance RB. This is perpendicular and this is also perpendicular. So this will look like this and this will look like this, and whole body is in pure rotation with respect to C, and this C is at rest. And same result we will apply. VA upon RA, VA upon RA is equal to VB upon RB. And this we will use this concept in previous questions. VA upon RA is equal to VB upon RB, and this is equals to omega. This is equals to omega. This is angular velocity. This is angular velocity, and unit of omega is radian per second, and dimension is T inverse. Is it clear? Now we will use this concept in simple example. Suppose we have a rod and this is angle theta and length of rod is L, and suppose this point is A, moving with velocity VA, and this point is B, moving downward velocity VB. And we have to find what is the relation between VA and VB and what is the velocity of center. Suppose this center is D. Then what will we will do? First, draw the perpendicular as the previous concept on velocity, and second on this velocity, and this will be the point of intersection. This will also our instantaneous axis of rotation. And as you know, this is theta, then alternate angle, this will also theta. So this is RB, and RB is equal to L cos theta. And similarly, RA is L sin theta. Same concept we will use. VB upon RB is equal to VA upon RA. So we can find the relation VA upon L sin theta, because the board is small, VB upon L cos theta. And as we see, L and L will cancel out, and sin theta when go in numerator, sin theta upon cos theta becomes tan theta. So VA is equal to VB tan theta. VA is equal to VB tan theta. This is the relation, and this is also omega. This is also omega, and omega is same for all the points of the rod. And suppose we have to find what is the velocity of D. What is the velocity of D? So first we join C to D, and as we know, the distance CD will equals to half of B, because this is a rectangle and this is a diagonal of length L, and this will also diagonal of length L. Therefore this CD is equal to L by 2. This CD is equal to L by 2. And for D, this will work as a radius. Now the D will move like this, perpendicular on this, because this is in pure rotation. This is the perpendicular line. This is a perpendicular line, so we can find VD. we can find Vd. Because as we know, this is CD we have known already, therefore Vd is equal to velocity of D is equal to CD into omega. CD is working as radius, CD into omega, and omega we have already find out, so we can find the velocity of D. This is our basic concept, and this is a good question which is asked many times in the exams. Okay, so this is by first based on topic instantaneous axis of rotation, that is very useful in rotation mechanics.